Welcome to the online portion of Ms. Truax's chemistry class. In this online segment, you guys will be learning the basics of organic chemistry and learn about the biomolecules that are inside of your body. So just to begin, we're going to review some of the basics of atomic structure in case it's been a while since we've talked about it in class. If we zoom in here, atomic structure has three major components. There are protons, electrons, and neutrons. Protons and neutrons, these ones, are found in the nucleus, and electrons, which are negatively charged, are found in shells outside the nucleus. Different elements have different numbers of protons and electrons and neutrons, and when you have more electrons, you end up getting more shells with more electrons. So that's some of the basics, so you guys remember. Now we're going to talk about the difference between organic chemistry and physical chemistry, which are the two aspects of chemistry. So if we zoom out again, we have these two aspects, organic chemistry and physical chemistry. Basically, the only difference between organic and physical chemistry is that organic chemistry deals with molecules based on carbon, and physical chemistry doesn't really base on carbon molecules. So let's zoom in on organic chemistry. Why carbon? Why is carbon so important? If you go back to your periodic table, carbon has six protons and 6 electrons. We know that because carbon's atomic number is 6. But why does that matter? So we know that when you draw an atom, that the innermost shell of electrons has 2 electrons, and the next one can hold up to 8. Carbon, since we already used up 2, has 4 more, so we have 4 electrons on this outer shell. Now that might not seem super important, but that means that carbon can form 4 different bonds, which is the most of almost all of the other elements on the periodic table. Because it can form 4 bonds at each of these places, because it wants to have 4 pairs of electrons to have a total of 8. Remember our octet rule, going back to our first unit, the octet rule. It wants 8, so each of the electrons are looking for a pair. So we can form 4 different bonds with carbon. This means that carbon can form all sorts of different types of shapes and structures. These are some of the structures carbon can form, the more complicated ones. You can see it can form structures like cubes, it can form sheets, it can form lines, it can form grids, it can form pentagons, or it can form hexagons. It can form all sorts of different things. So if you think about two common things, both graphite in your pencils and diamonds are all made out of carbon, just carbon linked together in different ways. You can see that graphite and diamond are very different structures and they have very different properties. Obviously, your pencil doesn't look like a diamond does, but this just shows how carbon can have very different structures even though it's all the same element. So we know that carbon can form lots of different things, but in organic chemistry, we're mainly focused on hydrocarbons, which is carbon bonded together with hydrogens in a bunch of different ways. The most basic of which is methane, which is a C that has its 4 bonds like it wants with 4 H's. Hydrogens, if you remember, hydrogens have an atomic number of 1, which means that they only have 1 electron. Since that first shell only wants 2, hydrogen can only ever bond 1 time. So you'll only ever see hydrogen like this bonded to a carbon 1 time, like right here. So this is your most basic hydrocarbon. It's called methane. You may have heard of it. Methane, or CH4, is in some of the greenhouse gases. For example, I think cows fart a lot of methane, so methane gas is something that's not great for the environment. But this is the most basic hydrocarbon. The next one that is a little bit more intense is ethane. So that is 2 carbons, so carbon right next to each other, and each one of those has, how many hydrogens do you think is going to be on there? Remember that carbon wants to bond 4 times, so if it already has 1 bond to another carbon, how many hydrogens do we think? You guessed it, I hope. There's 3 hydrogens on each of these carbons. So we can see we could just keep linking carbons together and end up with chains that can be as long as you want. The way that organic chemists write this is a little tricky. For example, this squiggly line I just drew is actually a hydrocarbon in disguise. Each end of the of each peak, so right here, here, those were all carbon molecule, and there's enough hydrogens on each carbon to make each carbon have a total of 4 bonds. So what it really looks like is this. C. I should have drawn a smaller one. And then each of these lines I'm drawing is going to be a hydrogen. The reason why organic chemists draw them this way is because you can see how long it takes me, there should be 3 on the end, to write all of these on here. It takes a long time. But imagine all the little lines. So all of these lines are hydrogens, and it becomes a little squiggly line of carbons and hydrogens bonded together. So that's the basics of writing hydrocarbons, right? So they can be lines like this, and so you can imagine if we have molecules like this, I told you that every point is going to be a carbon, so there are carbons at each of these points, and then hydrogens, enough to make them have 4 each. This is called cyclohexane. You'll notice that there are a lot of different ways to name organic molecules, and we're not going to go a lot into nomenclature in this session just because the biological molecules take so much time. But you'll notice that I've been saying ane at the end of all of my molecules. That means only single bonds. So ane is single bonds. If I said ene, those are double bonds. There's at least one double bond. And then ine is triple. Those are not things you really need to know right now. There's just some fun facts. And when I said this one, I said cyclo. So cyclo means it's circular and connected like this. That makes sense, right? Cyclo, circle. And then however many carbons there are tells you the main name of the chain. And there are a lot of different names, and they have to do with numbers. So it starts with methyl, and then ethyl, and then 3 is, I forget, but they go on, and so I think it's butyl, and then it goes on. You don't need to know these right now. Like I said here, some of them make a lot more sense than others. For example, hexane, right? Hex is going to be 6, pentane is 5. So you put them all together and you can make names of molecules, which is not what we're focusing on this unit. So we have all of this mess, but what we're really focusing on is how organic chemistry, how organic chemistry is different and important from physical chemistry. So physical chemistry is dealing with all of the other elements on the periodic table basically except for carbon and hydrogen. So when these are put together, carbon and hydrogen, also with oxygen, it makes up all the molecules that are inside your body, pretty much. There are some element, like trace amounts of other elements, but in general, your body is pretty much made up of mostly just carbon, hydrogen, and some oxygen, which is crazy, right? How do those 3 elements build up an entire working person that do all the things that working people do, that regulate body temperature and digest food and think and move and whatever? So it's crazy that just some combination of these molecules is going to make a whole person, right? And it all starts off from one cell. So if you guys did your biology already, you'll know that people start off as a single cell and then grow into a multicellular organism. So all of these came from the knowledge in one cell. But where is the knowledge in the cell, and how does that work? And how do molecules work together or look different to make your body work? So that's the whole point of this session. You're going to learn about the 4 main types of biological molecules and see how they work in your body. And that's going to be it. So the way this part of the class is formatted, you have until the end of Christmas break to finish. It's a short amount of sections. There's 2 quizzes and 1 final. Each of the quizzes you can take 2 times. So if you mess up the first time, go back, review the PowerPoints, then the lessons, and take it again. And then the final assessment is only to be completed after you finish all the quizzes and everything else. If you have questions, feel free to email me, but this is basically your crash course in organic chemistry, and I hope you have a fun time learning about how chemistry works in your own body.